Hey everyone, welcome to Joystick Lab, and in this tutorial we are going to talk about how we can create this procedurally generated 2D terrain using SpriteShape controller inside Unity 3D. Alright, so we are going to use the Perlin noise to generate a smoother terrain like the one that you are watching here. If you have ever played the hill climb racing game or Alto's Adventure, you should be familiar with this um, hilly terrain concept, and this can be used in many different places. This knowledge can be transformed into some other applications as well. So I'm really excited about this tutorial. So without further ado, let's get started. If you are new to this channel, please consider subscribing because we talk a lot about game development contents and AR VR, which might be interesting for you. All right, so let's create a new scene. Let's start from the scratch. I might extend this tutorial into two parts if I see this is getting bigger, but yeah, first let's create a new scene, and we are going to include some packages. I already have them, but you might need to add them in your project. Make sure you're using any Unity version bigger than 2019, and also make sure you have this tile map editor and SpriteShape, these two plugin installed. All right, so what we are going to do here is basically let's talk about the logic first, like how this thing is going to be working. So I'm going to create a new object, 2D object, SpriteShape, and if I look into the property of this thing, this is pretty cool because this is just not an usual sprite. This is a sprite shape which you can basically deform. All right, so basically you can use these corners and you can draw different sort of shape using this sprite shape controller. Now the benefit for our purpose here is that if we say have this 2D sprite shape controller, and then if we keep adding point, first of all if we first of all make this two edge point bigger to make my terrain longer, then in the middle I can basically add a few points, and we can use these points with the help of these tangents. We can make this terrain look like a curvy hill. All right, and obviously we need to do this using our code. We are not going to do this manually in the editor. We need to do this in an automated way from our scripting. So that is what we're going to do today. But before moving into the code, I want you guys to I want to talk a little bit about what sprite shape is. I'm going to basically create a new profile for this sprite shape so we have some sort of familiarity with this tool before moving on to the code. All right, so yeah, so from the right, you can see a few options. The first option is a profile. This profile is basically going to be some sort of profile that you use to draw some texture on this. This is going to give you the actual graphics into this sprite shape. Then we have this spline. The splines has three different tangent mode. We're going to use this tangent mode in many different ways to draw a particular shaped terrain. So for example, if I was to use the first one, then you can see it's completely straight, right? There is no curve at all. If I use the second one, I have these two lines in the two like two section of this point, and when I move one of them, the other one is basically moving as well, so they're dependent. The third tangent is kind of same as the second one, but now we have control to both of this, all right, independently. So we are going to use the middle one mostly in our code. Then we have this position. So basically when you click on of this point, you are going to get this position. This is basically the position where this point is landing in this screen, not screen space, wall space. Okay, we have this height. I'm not sure what does that do. Corner disabled, I am also not sure what does that do. We're not going to use that much, but if you have more question about this, go to the Unity's official page, and they have some tutorial on the SpriteShape controller. If you are interested, like if you want me to create some tutorial, put a comment there in the comment box, so I'll make a tutorial. I'll learn this and I'll make a tutorial for you guys. All right, so these are the basic control, and then we need to understand how can we create a profile. So let's create a profile. I'm going to right click, create, and I'm going to look for sprite shape profile, and I am going to create this closed shape. Now again, there are different sort of shape. There are two different shape, basically open shape and closed shape. I'll talk about that just in a bit. I'm going to first create this platform 2, and there are, as you can see, currently in this profile there is 4 section. If I select them, this is the first section, this is the second section, this is the third, this is the fourth text section. Now what they essentially do is basically they give you the ability to assign different sort of sprite for different phases of the terrain. So what does that mean? If I kind of delete this and create a brand new one that is going to be more easy to understand. Let's say I am going to add a new sprite in here. And why did I do this? Why did I use this one? Because this is up, so I want to apply the sprite in the up direction in this way. All right, this one I can add a new sprite. I can use this one. This might not be helpful. Maybe I want to use this. No? Yeah, looks like I need to use this, right? Yeah, anyways, I'm just going to use the middle one. Okay, we'll see what happens. Yeah, and then we are going to use the other one. We are going to use a new sprite here, and that is going to be this guy. Although this is going to be inversed. Again, this might be confusing for now. Like I said, I'm going to put a link in the description where you can learn more about this concept. This is not the topic that we're going to talk about in our lecture, so I am just doing this really quick. All right, so yeah, if I now drag and drop that platform, as you can see, that has been applied to our sprite now, and that is not all correct. So let's make this okay, that will work for now. And then also for this one, I am going to use this. Now if I click on this and if I select one of this corner and I bend it, you'll see it looks much better now. All right, now the center, you can see the center is empty. We can fix that by selecting a texture that is going to be the fill. The fill is going to be this one. All right, we can add some offset here, but I think this is good for now. All right, so yeah, that's all about it. Let's save it. I'm going to make this, reset this, and just gonna put the default settings here. All right, now what we are going to do is basically start typing our code. Oh, one thing before I move on. So this is the open-ended, closed-ended thing. So if I make this open-ended, then there should not be, any sort of this internal spaces. But if this is a closed area, then it's going to be like this. All right. Yeah. Okay. Yeah, you can obviously make this more smoother using some techniques inside here. You can add some more angles, right? We can add more angles by dragging this, and then for that particular angle you can add a particular sprite, but I'm not going to do that just for now. All right. Okay, so the next thing is to create a new C# script, and I'm going to name it platform. I'm going to create a new C# script, and I'm going to say train creator. Let's open this up. Okay, so I already have this like built-in stuff that comes up with the template, so I'm going to delete that. And then the first thing that we need is the reference for this sprite shape controller. All right, so let's create a new variable, public sprite shape controller shape, and in our start method we are just going to initialize this shape. All right, next up we need to scale this whole terrain, right? So the terrain is now this small, we need to make it bigger, like really big, right? But we cannot scale it because you can see if we scale them it's kind of getting broken. All right, so we cannot scale them. We need to do something else. What we can do is take the two endpoint and then we can just change their like x positions, right? So let's do that. We are going to take the last 2 points. Now this points has a index. The index are basically assigned in a anti-clockwise manner. So that means this corner here is 0, this corner here is 1, this corner here is number 2, this is number 3. All right, so this is a sequence how the points are getting the index. So we are going to keep that in mind, and we need this, not this one, we need this point, number 2 point, and number 3. We are going to use this 2 point and we're going to change their positions, right? To do that we need to again go back to our code editor, and in here we are going to say the shape dot spline dot set position to, this is the index and then the point, right? So the second index we're going to change, that's the position of the point in the index second to the current position of this guy, and then we're going to add a few offset there. All right, so let's add a new variable that is going to be our scale, public int scale, and we want it to be something like 100. All right, so let's duplicate this and change this to index 3. If I save my script, go back to Unity and drag and drop the terrain creator, and if I play, as you can see, we have a really like long sprite shape. All right, now all we need to do is we are going to use this sprite shape and we're going to just keep adding some points in the middle, right? We're going to keep adding point in the middle, and for each of the point we can just add some height. All right, so let's do that next. Let's do a for loop, right? So because we are going to do we're just going to draw some points, so we are going to need a for loop for that. we're going to draw 150 points. I'm hard coding it, but you can obviously expose that to actually let's do that. Maybe public int this is going to be 150. Public int, we are going to need some distance between those points, right? Distance. Now, here we need to calculate like where we are going to insert the point. Basically, the method to insert a point is like this. I think insert point at, right? So first of all, we need an index. Let's figure out what index do we need. Again, this is 0, this is 1, right? So we want to add point after that, right? So we want to add point from 2. So from the location 2, we are going to keep adding point. So to do that, we are going to say I plus 2, right? So when the point starts with 0, the first point that we are going to insert is going to be 2. So this is going to be where we're like the index where we want to add the point. Now we need to actually add the location. Now for the location, we have already talked about it, that the x value is going to be this, right? So if the x of this is say 3 or something, then we are going to add something with that x. Then we are going to add some more value with that x. Then we are going to add some more value with that x. Add some more value with that x. And we are going to keep going until we reach here, right? So we are going to basically keep adding points from 1, and we're going to get the location of point 1, and we're going to add some offset to find the new position. Right, so new vector 3, we are going to take that position. Maybe we're going to use a float variable to load that like keep a record of that particular point. Get position I plus 1. Why I plus 1? I already mentioned, because we are starting from point 2, so we need the position of point 1 and add something with that. All right, so that is why we are adding up a 1. So the first point that we are going to add up with is 1. 0 plus 1 equal 1. Okay, so we're going to take the x of that guy, and then we're going to add a offset that is going to be the distance between the points. All right, I hope this is clear to you guys. Okay, then we need to add this x position, and for the y position we are going to make it random. All right, so just for now we are going to add a random number, random dot range. I want to get a random number between 0.0f and 1f. All right, and then I'm going to multiply that with some number. Maybe I can multiply that with 10. Now let's go back to Unity. Let's play it. Let's see what happens. Oh, so we need to clear this a little bit. Yeah, because we already had a few points, that's why we got that weird thing. Yeah, but this is more weird. So yeah, we're going to make this look nicer in a bit, but now you can see we have this peak that giving us some kind of hilly effect, but obviously this is not what we want. So let's do a few things before we move on. I'm just going to keep my terrain started from here so it looks more natural, and then we can go in here and we are going to add some carb in the points, right? Because they are now kind of triangular. So let's add a few carb, Now you see we are we have started from I plus 2. That means we need to start adding the, like, you should start adding the curve from point 2, right? Because that is where our first point is, and then we need to go until 152, because here we are going from 0 to 150, so we need to go from 2 and 152. There are a lot of ways of doing it, and this is not obviously the best way of doing it. I'm just making this short. Maybe I'll come up with some more better stuff later on. Yeah, so we are going to add the tangent. So set tangent mode in the index I. The tangent mode should be continuous, right? Continuous means the middle one, and continuous means this one, right? So we want the middle one. This is what we're going to need to make the curve smoother. So yeah, then we are going to, so this is by default doesn't work, so we need to add the left and right tangent. So let's do shape dot spline dot set left tangent, and we are going to add vector 3. Actually, maybe do new vector 3, and in the left direction I'm going to go to -1. If you have some idea about tangents, you are going to understand that really easily what is happening, but I'm going to talk a little bit about that just in a bit. Shape dot spline dot, and we're going to do the right tangent to same location, but now we are going to use +1, right? Okay, so now what we are basically doing here with this plus and minus sign is that when we are saying the tangent should be -1, then we are just saying in x-axis. So we have a point like this, we should add a tangent just in x direction. There shouldn't be any y or z, so that means it should be straight in x direction with -1, and we're also going to do that the same in the right direction, +1. That way, if we stretch that, that will create a curve. Okay. To learn more about it, you need to learn a little bit of trigonometry and how Bezier curve works. I'm not going to talk much about that, but if you have question, if you want me to make some tutorial on that, put a comment down below. All right, so yeah, now if we go back in Unity, we'll see we have some sort of curve, right? So we are almost going there, but still we have some irregularities, and the obviously it doesn't look that natural. All right, so this is the this is the property of randomness. So random number generates any number in between the range that you gave without even thinking about the previous like input, right? So that is where Perlin noise come into. So Perlin noise takes this randomness and it makes it smoother. So there is a relation between the previous result and the next result. All right, so we are going to basically replace this concept with the Perlin noise concept. All right, so this algorithm was developed by the scientist called, his name is Ken Perlin, and he got some sort of academic award for this, and this is one of the like most used algorithm in computer graphics. I'll put a description here in the comment where you can learn more about Perlin noise in detail, but we are just going to use the default Perlin noise method that Unity gives us. Okay, so we can use math f dot Perlin noise to generate a Perlin noise. We're going to use this is a one-dimensional Perlin noise, so that means there is only one change happening, that is just the height, right? So we are going to use one-dimensional Perlin noise. We're not going to consider the y. Now here the important part that we need to consider is that Perlin noise always gives you same value when the number I, if I just put I, it is going to always give us the same number, right? Because when it generates the random numbers, it flats all the value when the values are like whole numbers, 1 2 3 etc. So we need to make a fraction to make it work. All right, so to do that, what I'm going to do, I'm going to just add a little bit of randomness in here. I'm going to multiply the random function. Now there is a lot of ways of doing it. I am doing it in this way, but you can play around with it and you can see which one suits better with your needs. All right, I'm just going to do 15f. All right, so this is going to give me a random number in between 5 to 15. Hopefully there should be fraction, and then I'm going to multiply that with I. That will give me a Perlin noise value. All right, and then I'm passing that value into my Y rather than just a simple random. So now the random should be a lot more smooth. All right, so yeah, so let's head back to Unity and see what did we get. Now as you can see, we have a nice flat terrain, right? Nice flat terrain. Now what we're going to do from here is I'm just going to show you guys that this is the point that we just created, right? And when I was talking about the tangent thing, this is what I meant. So this is the x, right? This is the negative x, this is a positive x. All right, and yeah, so let's scale it a little bit. 10 multiplied by Perlin noise, so it has some sort of, you know, hilly bouncy stuff. Yeah, now it looks better. Now as you can see, there is one problem in our generation, that this thing is basically really sharp, right? But we have a solution for that. As you can see, if I increase the length of this tangent, right, then I get a more smooth edges. So to do that, we can just increase this value, right? So now in both direction we'll have some more larger amount of tangent value applied. Yeah, it's a little bit too much but yeah, you got the idea. All right, so that's all about it basically, guys. But before closing up, I want to show one last thing to you. Basically, if I move more to the terrain, you'll see, first of all, we have this problem where we are getting this square kind of, you know, cut off. And also if we move further, we are going to get some overlap and some irregularities in our terrain, for example here. So let's fix these two things and then we are going to be done for the day. Let's open up my script. Now in here, okay, so first thing that we need to consider here is that, see, we are getting around 150 number of like points, right? And each of the points has a distance of 5, so that means the total distance should be 150 cross 5, which is I don't know, 750 points. So but we have a scale of 100, right? So that means there is a lot of points that should not fit into the terrain, so we're going to get some overlapping and irregularities in our terrain, right? So let's fix that first. So we are going to, first of all, I'm going to make this scale to 1000, and then when I am applying this distance, I am not going to apply it here, rather than I'm going to apply this in here, and I'm going to calculate the range by simply dividing the scale with the number of points. All right, now there should be that it should be problematic because both scale and number of points are int, so I am going to make it floating point, and yeah, so that way we can always ensure that all the points should fit in the scale. Okay, so save it and let's go back to Unity and play the game. Wow. Okay, so we're getting this sort of problem. So all right, let me figure it out. All right, the first problem that I can see here is that the editor has not updated the value that I have like updated in my script. So the scale was not 1000. Let's play again. Now we can see we have this better terrain and there is no irregularities anywhere. All right, so the points are all placed perfectly. So that's all about it, guys. Actually we don't need this float. On off the float is fine. All right, yeah, so let's finish the class here for today. If you like the video, please press the like button, subscribe to the channel if you are new to here. Also, don't forget to put the bell notification on so you can get the updated notifications of the channel when I publish a new video. I'll see you in the next tutorial. Bye.